Okay, good morning, everyone. Sorry, I had to restart my computer. My Zoom is acting weird. You can hear me, see me? Jose, yes, thumbs up, okay. All right, everyone, welcome to Math 1414 College Algebra for STEM majors. My name is Robert DiGiovanni. I'm hoping that most of you have seen me already because you watched the orientation video. I have a list here of the students who actually followed through and did the assignment that I gave in the orientation video. Anyone want to take a guess as to how many people actually did it out of 22? 3, Javier? 5, I've got 1, 2, 3, 4, 5, 6 people. So 6 out of the 22 actually did the assignment that I gave in the orientation video. So, all right, well, it is what it is. All right, let's get to some business administrative stuff first. So let me get into Canvas. Now, the orientation video, I go through all of this, so I'm not going to do all this again, but there are some important things I need to point out. Okay, so here's the main page. The orientation video is here. I sent it out in an email also. Make sure you watch the entire thing because there's an assignment that you're supposed to do at the end. Now, one of the most important things, at least right now for this class, is that in the syllabus, 15% of your grade is quizzes and participation. So what is part of participation? Can somebody tell me? See, Jose, Javier, and Diego, maybe you can tell me.
Have your camera on.
Have your camera on.
Most of the class.
Most of the class. So I do not expect you to have your camera on all the time, okay? But just because this is a Zoom session does not mean that you get to just be there with a name up on the screen. I want to see that you're there. I want to see that you're engaged in the class. I was doing a class yesterday, and there was a guy, he was on camera. At least he had his camera on, but he was like just cracking up and laughing and stuff. And I knew it wasn't what I was doing, it was something else he was watching, fine, whatever. If you're going to watch another video or something, or, at least have your camera on so I can see that you're enjoying yourself. All right. So that is part of participation in the class, is to have your camera on. If for some reason you can't have it on, that's okay. Just, maybe send me a chat or an email saying, hey, today I can't be on camera, whatever, I understand. All right. Any questions on that? Okay. Any questions over the syllabus or the expectations of the course? No? I was hoping somebody would be willing to share, let them share their screen and log into the software to show like where you go to do the homework. Because from my perspective, I can't see what it looks like for you. So I want to make sure that no one's having an issue with it. Does anyone want to volunteer to do that?
I can do it.
Okay, so I'm going to make you a co-host. And you'll be able to share your screen. Let me stop sharing mine. And then whenever you're ready, is it Sana? Is that the way I say that?
Sana.
Sana. Okay, so Sana's going to share her screen here in a moment.
Okay, can you see it?
Yes.
Okay.
Okay, so if you could go to like the main Canvas page for our class, wherever that is.
Here.
Right there. Okay, yeah. So so for everyone, what we're doing here is Sana's going to show us how to get to the ebook and to where the homework is. So go ahead, let's see.
Okay, so the ebook is here, right?
Yes, should be. And this is the first time I'm seeing it from the student's perspective.
Oh, okay, so
now I think read now we'll just open the book, but you want to launch courseware. that's where you go to do all the homework. Have you done this yet or no?
No, I actually
Okay,
haven't.
good. This will be a first time thing. Let's see. Okay, great. Now open that yellow tab up top, open My Lab Mastering. And this is where you will blindly agree to all the terms and conditions. Okay. All right, do you have an account?
I honestly think I do from high school.
Okay, yeah, you know what? Okay, so at this
I'll create
point,
another one.
I think this is good enough. This is where you would create your account, or if you have an account, you use your old account. We don't have to go through all of this, Sana, but that'll get you into the system, okay, where you can go and do your homework. Has anyone done that yet? No? Okay, so maybe next class we'll go through it again.
I have.
I'm sorry, who
I
has?
have. I have.
Ashley?
Ashley.
Okay, so do y'all want to go in through Ashley's, if Ashley's willing to share and see what it looks like, or you okay to set it up on your own? What do y'all want?
I'm okay to set it up on my own.
Set it up? Let's do that. Let's just let everyone kind of figure it out. And then once you get it figured out, then next class, if you have any questions, you can let me know. I'll go in and I'll show you what it should look like. And then, you know, I think you can figure out how to do the homework. I'm going to go into the system today and actually show you. So, all right, Sana, you can stop sharing. Thank you very much for at least doing that for us. All right, let me get my screen shared again. I apologize, my voice, I'm getting over something. My wife had COVID, but I tested twice and I was negative, so I don't know, but I was not feeling well for about a week, but I'm getting over it. I feel good. I just sound like shit. So, all right. So this is our syllabus. Let's talk about the next thing, which is to make sure you're in the right class. So I'm assuming here everyone is a STEM major. So that means most of you need to take pre-cal, right? And if you're like a business major, or if you're a nursing major or some other humanities major, you actually don't need to take this class. You can take kind of a easier watered down version of this class. That's especially good for students who are maybe not, like math is not their strong suit. They don't really care for it. Does anyone feel like maybe they might be in the wrong place?
I just want to make sure if I'm majoring in biology for like dentistry and
Yeah, you're in the right place.
Okay.
Most biology majors nowadays have to take at least Cal 1. Most, and some have to take Cal 2.
I have a question too. If I'm majoring in kinesiology, would I need this?
Good question. Hold on, let me look here. Math paths. All right, so this is the chart that we have to kind of guide us through. Right now, we are. Oh, whoa, what happened? Okay, so we are. Hold on, I got to bring up one more program. Give me a second. I know y'all are all very eager to get into the math, so just hang tight. We'll do math in a moment. All right, so this class, Math 1414, feeds into all STEM majors. So business, education, nursing, liberal arts, those all have different math requirements. Not requirements, they're courses that will feed into those majors better than this one will in terms of making it a little easier for you to do. Not quite sure where kinesiology lands in here though. Not sure. I do not think kinesiology is STEM. I do not think it is. So I think you might have to talk with an advisor on that. Was that Isabella asking?
Yes, sir.
Yeah, you might have to check. Does anyone happen to know that? Is anyone here a kinesiology major? Yeah, I think this might not be the right class for you. So why don't you do this? Do you want to stay here today and continue, or do you want to bail out, go check and see if you can figure that out? And then if, I'm going to record all this, so you could always come back and watch it if you wanted to. It's totally up to you. I'll let you decide. But I think you need to look into that.
I'll stick around just for today, but I'll
I
definitely
know it
look
looks
into
fun,
it
right?
after class.
Okay, great.
Thank you.
Okay, good. Any other questions? Okay, so, this whole math path stuff is kind of crazy. Like for a long time, when I was a student, went into college, there was only one math class you could take for college algebra. It was called 1314. It's college algebra. And basically you had to go through that class to get to basically all degrees needed that class. And what was happening is students were coming out of high school and they just weren't ready for college level math. Now, we could have a whole semester of discussion on why that's the case, but the high schools weren't preparing students for college in the math part, right? So students were coming to college and then they couldn't get a degree because they couldn't get through the math requirement. So there was a decision that we would make college algebra have two different tracks, the 1414, which is what you're in, and then the 1314. So the idea here is that all of you need more math. So I have to teach this in a way that you're going to wind up in one of my calculus classes, and I need to make sure you understand how to do algebra. Okay, so it's very important that the standard here is held to, the expectations here are held to a certain standard. All right. I personally am not a fan of this. I wish it was just one class. It's kind of like English. I had to take English when I was in college. I had to read books and write papers. I hated doing that. I wish they would have had like an easy English so that I could just not have to write papers and read books. I don't know why we've done this for math, but this is what we've done. So anyways, the class you're in is what I would consider to be the normal college algebra, the way it would have looked 10 years ago, 15 years ago. Okay. All right. Any questions on that?
I have a question.
Yes.
So I have to take 1314, but last semester I took 1414 and I didn't have to take 1314.
Wait a minute. If you take 1414, which is this class, it is a better class than 1314. So anything that had the 1314 as a prerequisite, the 1414 will fill in for it.
Oh, yeah, because whenever I was signing up for my classes, it told me I had to choose a 1314 class in order to take 1414.
You had to take 1314 in order to get
Yeah,
into
like
14?
I had to sign up for a 1314 class.
That's something's wrong there. So you took 1314?
No, I took 1414 last semester.
Okay. Got you. You're just retaking it? Is that my
Yeah.
Okay.
Yeah, I dropped it.
Okay.
But so then I should drop 1314.
Yeah, you're in 1314 also?
Yeah.
Oh yeah. No, you don't need that class. It's one or the other.
Okay.
Yeah.
Thank you.
Yep. I don't know how that happens, but it shouldn't have. It shouldn't have asked for 1314 to get into here. Okay.
If you took math, I think it's 0320 or 2030, something like that.
Yeah,
would
that
just
class feeds into this.
Yeah, it helps
0320.
refresh kind of before we take this one.
Exactly. That's a class you can take before you get here.
Okay.
Yeah. Now, I'm not sure how many of you took that, but that class right there is supposed to prepare you for this class in the event that you came out of high school and just weren't quite ready, or came back to school, whatever your situation is, weren't quite ready to get into the 1414. And so we put you in here. Anything else? So like I said, the thing that I do the most, I've been teaching at the college for 20 years now. I can't believe it's been 21 years. It's crazy, time flies. I teach mostly the calculus sequence. So I teach, Cal 1, Cal 2, Cal 3. That's kind of where I like to be. But every semester I'll teach a pre-cal or college algebra, and I'm even teaching a 13, 14 this semester. So the good news there is that I know what you need. Okay, so like I know what you're going to need to get through calculus, the algebra. I guess the bad news is that I'm going to hold you to that certain standard to help you, right? I need to help you be able to be successful in those courses. So I guess the big thing here is that, math, you're going to have to practice. You're going to have, if you haven't learned that lesson already, you need to know that, math is going to be you doing, right? Practice. You can't just watch me do problems and be like, oh yeah, I got it, right? And then also to reach out for help. All right, I'm here to help. So hopefully you can take advantage of my office hours. If not, I've provided my cell phone number and everything, so you can contact me. Again, watch the orientation video. I sent out a survey yesterday, I think, about changing my office hours. And I'll share with you what I have so far. I've had 73 responses so far. I have about 130 students total this semester. So this is more than half my students. And it looks like about 80% of my students want me to keep my 4 o'clock to 5 o'clock office hours. So it doesn't look like I'm going to change them. But if you haven't filled out the survey, there might be enough people here to sway that a little bit. This is just a certain time slot where I'd be available to you. So, okay. Anything else administratively? Questions before I begin? In that survey, I asked people for some feedback, and I've been reading through them, and it's pretty interesting, how much people are trying to balance work and school, and it's a challenge. A lot of times when you get to a university, you'll be around students that's all they do, right? They just go, they're students, that's all. They don't work, or if they do, it's just part-time. A lot of students in the community college work full-time, have families, they're trying to balance everything out. And so you just have to kind of make sure you're being realistic with yourself in terms of what you can accomplish. There's a reason that, you don't drink water from a fire hydrant, right? If you want to go get a sip of water, you go to a water fountain and take a drink. You don't go to a fire hydrant, open it up and try and drink from it, right? Same thing with education. You can only absorb so much material at one time, and trying to balance life with that and work. So you have to be realistic, okay? Be realistic and don't try and overload your plate. I always tell my students, look, don't rush to get through college, all right? You're talking about setting yourself up for a career that's gonna last maybe 30 years, right? A career. So if it takes you an extra year or so, 2 years, an extra 2 years to get your college degree, but you can do it in a way that you can manage your time in life, then take the time, right? It's not throwing yourself into a brick wall, taking 15 hours and working 40 hours a week and all that. You're just hurting yourself by trying to do that much. So, thank you for the feedback. We'll see how the first test goes. If you're struggling, I may look back at that and be like, hey, maybe you need to cut back a little bit here, not try and do so much. But I tell students that every semester, and no matter, people will still try. So just realize that the lines of communication here are open, okay, between me and you can reach out to me anytime, talk to me about your major, your life, whatever. I'm here to try and be a mentor to you if you have any questions about your path, all right? Okay, so what is college algebra about? Well, college algebra is one of those courses where it's kind of anticlimactic, all right? Like in a calculus class, we usually start out and I'm like, okay, let's look at some problems that right now we can't do And then at the end of the semester, we're gonna be able to do these. And it's like, wow, cool, you know, that's a goal, right? For college algebra, it's more like, I'm gonna show you a hammer and I'm gonna give you a nail. I'm gonna say, okay, this is how you use a hammer. And then I'm gonna do screwdriver, and I show you all these different tools, right? That's what college algebra is. It's a bunch of tools. And then later on, when you get to higher level classes, you start to build something with those tools. So this is, you know, college algebra is just really us making sure that we have like a toolbox that's full of tools that we know how to use. And then later on, when we actually go build something, we're like, oh yeah, remember that, open the drawer, go grab your tool. That's what college algebra is about. So I'll try to show as much as I can how we can connect the college algebra to the real world, and I'll make connections when I can, but really at the end of the day, we are just building up our abilities to do math, higher level math later. Okay, so just keep that in mind in the background. All right, I think I'm ready. So we're going to get into today's material. I'll try to remember to do this every day. I'll try and tell you what we're going to do today, and then the homework assignments that are due for today. So I just changed the schedule, like 10 minutes before class. I updated the schedule in Canvas. So if you printed it out, you're gonna need to print a new one. All I did was change the due dates. This is our schedule that you can find in Canvas. These due dates were actually, I didn't like the way it was set up. It was set up to be due, it needed to be one day earlier. So basically everything got pulled back one day. So your assignment for tonight, or for today's class, we're going to cover R2 and R4. You will go into the link that Sana was showing us to do your homework. You'll do your homework online. It'll be due on the 23rd. Those two sections are due on the 23rd at 11:59. So the 23rd is Sunday evening. We have class on Monday morning, right? So it'll be due the night before class, our classes, right? It was set up to be due Monday night, which doesn't make sense. I want it to be done before we meet. And my expectation is that whatever I cover, like today, whatever I cover today, the next time we meet, you should know how to do those problems. And that goes for the entire semester. So if we meet on a Monday, whatever we cover on Monday, on Wednesday, I could give you a quiz over that. So that means you are responsible between Monday and the next time we meet on Wednesday to have done your homework. If you're having trouble, reach out for help to me or to Tutoring Lab, all right? And then I could give you a quiz. Any day, anytime, I could throw a quiz at you. And it could be, hey, everyone, take out a piece of paper, do this problem, and when you're done, show it to the screen. And then everyone shows their camera, their answer, and then I go back later and I check them. Or I could have you submit it, or I could do a poll where you have a multiple choice. I could give you a group quiz. Anything I could think of could come. So you just need, your job is to just be prepared, having done your homework, and ask questions if you have it. All right. Okay. I'm ready. I'm going to do R2 and R4 today. And then your homework will be due. And then next class, we're going to cover R7 and R8. We're actually going to probably start R7 today, but we're going to continue it. And then we'll do R8. We'll probably get into 1-4. And it's possible I may give you a quiz right off the bat next week on Monday, just to kind of keep you, just to give you that, that sense that, okay, I'm going to have to stay on track here. All right. All right. That's what we're doing. So what does the R stand for R2, R4, R7? What do you think that R stands for? Because that's the chapter. That's the name of the chapter. What do y'all think?
Rational.
Rational? Seems reasonable. Review. That's what it is. Review. All right. So this first 4 sections that we're covering, the first 4 sections on our calendar, R2, R4, R7, R8, are all review sections. These are things that you should already be familiar with, but let's just make sure that it's kind of fresh. Let's get it kind of at the front of your brain instead of way back in the cracks of your memory somewhere. So we're going to review. The first 2 days of class are going to be a review. And then once we get to 1.4, or then we start moving through the material, and we kind of jump all over the place in this class, but these first 2 days are going to be review. And the reason I'm telling you the review is because the way I'm going to present the material is not the way I'm going to do it for the rest of the semester. When we get to like 1.4, I'm going to kind of treat that like you haven't seen it. And so I'm going to present it in that manner. Here, I'm not going to do that. I'm actually going to go directly to the homework right now. I'm going to go right to the homework problems. I'm going to start working out homework problems. And then as we work them out, I'm going to ask the class, hey, okay, what do you think about this? I'm going to call on you every day. You need to be ready because I'm going to call on you. I have 4 screens in front of me, okay? And one of them has the entire class. And I'm just going to randomly pick students every day. And you'll probably be called on once per class. And I'm going to ask you to help, all right? And hopefully that'll keep the Zoom session a little more engaging rather than you just sitting there. You'll be kind of on pins and needles a little bit, waiting to be called on. And I just want you to know when I call on you, if you don't know, if you're confused or whatever, who cares, all right? I don't want you to be embarrassed. I don't want you to feel like, oh my gosh, he's humiliating me. It's not what it's about. This is about if you don't understand something, I'm sure someone else doesn't. And we can start to identify where your weaknesses are, where your strengths are, and I get to know you a little bit, all right? So I'm going to work through these problems. I'm going to go right to the homework. I'm going to start calling on people, and we'll see how things go, all right? So let's do that. Any final words before we dive in? Questions? Let me see, I'm in the right place. Never mind. I want to go, so I'm going to go into the courseware just like Sana did earlier. I just think it's going to look different because I'm the instructor. So this screen is going to look different for me than it does for you. Maybe I can do a student view. No. Oh, view student home. Okay. All right, so maybe this is what it looks like for you. Has a calendar. It has the assignments that are coming up, completed assignments. So these assignments have to be done, you know, by the deadline online. And I don't want you to get frustrated with the software, all right? Like, don't be like, because when I did the homework on here, it frustrated me, the way it wants you to type answers in. Let's not get bogged down with that. Your tests are going to be paper and pencil. So that's the most important part of this, is that you understand how to do the math. So I'm going to get into this, all right? Let's get out of here. Go back to my view. Algebra essentials. Algebra essentials. So this is 21 problems. And I don't know if I'll work through every one of them because some of them are going to be similar. If I feel like everyone kind of gets it, we'll move on. That screen is hidden. There it is. All right, so this is what the homework system kind of looks like when you open it. Here's a problem. I'm going to have to maybe zoom this in to make it a little bit bigger for you. Yeah. Can you all see that okay? All right, so what I'll do here is I'm just going to write on this screen. And then, of course, this will all be recorded. You can go back and watch it if you need to. The question is stated here. And then here's where you put your answer. And I already did this problem. So it says, write the following statement as an inequality. Write x is less than -3. So I put my answer here, x is less than -3. Now, just so we're all clear on what inequalities are, we have 4 different inequalities. We have this one, this one, this one, and this one. All right, so these are our 4 inequalities. these two are different from these two in the sense that these are called strict inequalities because it's saying that you have to be less than or greater than, but you can't be equivalent to. These have the bar underneath, which means you can also be equal at the same time. So let's try and visualize this on a number line. If we say that x is less than -3, what we're saying is that if you take a number line, let's say here's a number line, and you go to -3, your x values, these values right here, x, have to be smaller than -3, which means which side of it? Smaller means which way?
To the right.
To the right,
To the left.
to the left?
To the left.
Smaller is always left, always left. All right, so this means that if you pick any number over here, that number, anything over here, call it x, as long as it's to the left of -3, it would be smaller than -3. So we're trying to represent all of these numbers to the left. Let's see, yeah, this way. But we are not including -3 itself. So there's a couple of ways we can do that. We can do a parenthesis here. That's the way this system does it. They use a parenthesis. If you want to include the number, they'll use a bracket. Does this all look familiar to you all? Inequalities, have y'all seen this before?
Yes.
Okay. So we'll have more practice with this. Let's move on to the next one. All right, write the given statement as an inequality. X is less than 33. All right, so I'm going to come in here. I'm going to type in X less than. Now I have the symbols here, but I can also use my keyboard and just use the less than symbol on my keyboard. Less than 33. Hit enter. Good job. I'm done. That was pretty much the same as the previous one. Let me go to the next question. Okay, X is less than or equal to 36. So now the difference here is that we have less than or equal. So that's the other inequality. Number line, if this is 36, less than or equal means that we are over here to the left, less than, but we can be equal to 36. So we put a bracket here to represent everything this way. So the way I put the answer in is I put X less than or equal to. If I hit less than or equal to on my keyboard at the same time, like if I type in this symbol and then the equal sign on my keyboard, it will put this in for me instead of having to click on it. All right. And then what am I going to put here? 36. I have a question. Would this have been correct? Could I have typed this in? What do you think? Is
No,
that the
because it
same?
will means that isn't that greater than or equal to X?
So this says that 36 is bigger than or equal to X, right?
Yeah.
So it's still correct.
So, but it's the same thing, yeah. Because this one, if you look at this one, X being less than or equal to 36 is the same as 36 being greater than or equal to X. That inequality could be written one of two ways. In fact, I want to type it in the other way and see what the computer does. 36 bigger than or equal to X. It took it. It should, all right? So just remember that about inequalities. If you have them written down, you can always just flip it the other way and it should be the same. All right, let's keep going. All right, for here, this problem, it says graph the numbers X on the real number line. So now what they do is they give you this and they ask you to graph it. So I want to show all values of X that are bigger than -10, right? Bigger than -10. So I need everything to the right of -10. Do I include -10?
No,
No, no,
'Cause
because
it's not
there's no
equal
equal,
to.
right? So which of these would it be? Let's see, are there more options here? I might, So is it the first one? Well, here's
No,
-10. This is the stuff to the left that's less than, right? That's not what I want. How about this one? Bigger than -10 to the right? It has a parenthesis here, so I'm not including -10, right? This looks like the correct answer. Let's look at these two. D is almost correct, except it has a bracket, right? And we do not want to include -10, so should be this one there. All right. Evaluating an expression.
I have a question.
Yes, please
So-
interrupt if you have a question.
I've never used this this website before, or like the whatever. So what happens if you get a wrong answer? Will it let you keep trying till it's right, or it's just wrong?
You'll get another, so let's get one wrong, okay? So if I get this wrong, that's incorrect. It tells you a little hint on what to do. Let's see, try it again, got it wrong. Try it again. Okay, so I got it wrong twice, right?
Mhm.
On the third incorrect, it tells me the correct answer. And that's pretty much it, okay? Now I can ask for a similar question. It'll give me a new problem. And now if I get this right, it's okay.
Oh, okay. Okay,
All
thank
right.
you.
So you pretty much can like keep trying over and over. The homework is about practice, all right? It's about practice. It's not about, you trying to get perfect hundreds. Well, you want to get hundreds, but you want to do it like legit. You want to actually do the work and get it right. Because again, on the test, you're going to have to show the work and all that. So, all right, how about this? Evaluate the given expression. So what is the difference between an expression and an equation? Because this says expression, right? So if I write something like this down over here on the side, if I write x squared plus x versus x squared plus x equals 5, those are two different things, right? The one on the left is an expression. The one on the right is an equation. And the big difference between the two is that one of them has an equal sign, the other one doesn't, right? On the one on the right, I could actually solve this. I could go try and figure out what x values make this true. Here, if you're given an expression, there's nothing to solve. It's just an expression. It's just like, there it is, right? So here, what they're asking us to do is take this expression and evaluate it. What do you think they mean for me to evaluate this? What do I need to do here? Let's start calling on people so I can get attendance going. If you go by a different name when I call you, just correct me and then I'll type it in here and I should get it. From that point on, we should be good. Is it Malak or Malik? Malik?
Yes,
Um,
Malak.
Malak. Okay, so I said that Malak. Malak or Malak?
Malak.
Malak. Okay, so Malak. What do you think it means here when it says evaluate the expression?
Isn't it that you first put in like the numbers to like replace the x and y?
Exactly.
And
They're going to
then-
replace the x and y with the numbers they gave us, right?
Yes.
Okay, yeah, let's do it. All right. So I'm just going to take this. I'm going to take 4 and then it was x, but I'm going to replace x with -6. How should I write that? How about -6 in parentheses? Because it's being multiplied, right? That's 4 times x. And then plus y, which is 3. And then I divide that by 9 plus 6. And then times y again, which is going to be in parentheses 3. That's the way I wrote it. Okay, if you, maybe you wrote it different. Maybe you wrote 4 times -6 plus 3 over 9 plus 6 times 3. Maybe you use dots instead of parentheses. It's kind of your call, but you need to make sure you get the next step right. So Sierra, what do you get up top?
Can you hear me?
Pardon me?
I was asking if you could hear me.
I can hear you now, yes.
Okay. And I'm doing the,
Numerator, the top.
okay.
So we're practicing kind of order of operations here, right? We gotta make sure.
Right. Okay. So top first, 4 times. Negative 24
Negative 24, then we have to add 3, right?
plus 3.
On the bottom, we get 9 plus, let me erase this. 6 times 3 is 18, right?
Yes, sir.
Okay,
Negative, for the top, it'd be negative 21.
okay,
And then for the bottom, 27.
27, there we go. Okay, now at this point, we're done. I think, unless we can reduce the fraction. Now, to reduce it means there's a number that goes into both of these, which I do not believe, well, wait a minute, hold on. Is 3 go into both?
Yeah,
Yeah, we could do 3, so this will become -7/9, like that.
yes, sir.
And I think that's reduced completely. Let's see, what would have happened had we not reduced it? And also, I should point out, notice it says here, type an integer or simplified fraction. That means don't give a decimal answer. Okay, so if you just got your calculator out and got a decimal, it's not going to take it. It wants the simplified fraction. So let me see what would have happened had I not reduced it. It's probably going to take it, count it wrong. Watch, I'm going to hit this key. It's going to bring in the fraction here, -21/27. Wrong, okay? Because I didn't simplify it. So, okay, I got it wrong once. Let me try it again. 7/9. There we go. Okay. All right, next question. Good, thank you, Sierra. Is it Annika?
Yes.
How you doing?
Good. How are you?
Good. Okay, Annika. This says determine the domain of the variable x in the given expression. Annika, does domain ring a bell to you at all? Does that?
Yes.
So do you have a way of maybe kind of explaining what needs to be done here, or do you feel a little lost with this?
I know domain is like all the x's in the equation or something, and then I feel like the domain would be the -22 maybe.
Okay, so I think you're on the right track. I think that you're kind of in the right ballpark with this. Domain is basically asking for us to determine what values of x can be plugged into this expression. Can get plugged in. So the domain is everything we are allowed to plug in for x. When we look at this expression, there are certain values. In this particular case, there is one value in particular that we cannot plug in. And Annika, what did you say that was?
-22.
So -22. Well, let's see. If x is -22, what would happen? Be careful here. If I plug in -22 for x.
Oh, it equals 0 then.
Well,
Oh,
you said
no.
-22, so I put -22 here. If I put -22 minus 22, that's -44,
Oh yeah.
right? So what you need here is a positive to have a problem, right? If it were +22, then you would have an issue, wouldn't you?
Yes.
Okay, is everyone good on that? If x was 22, we would have division by 0, wouldn't we? And we are not allowed to divide by 0. Why? Why can't you divide by 0?
because it just.
Someone told you you
Yeah.
can't, right?
It's nothing.
It's nothing.
It's-
So it's 0?
Well, you can't divide by
Because the
zero.
answer
then
wouldn't
you
exist.
just-
Then why can't you divide by 0 though? I mean, I know we all have heard that, right? But why not? Why can't you divide by 0?
Because the answer
Could
wouldn't
be
exist.
wrong, but it doesn't it stay like undefined?
It's
Yeah.
undefined, exactly. But why? Diego, what did you say?
Because the answer wouldn't exist. We have no way of knowing what the answer could be.
But why? I don't understand.
Because-
Why not? Why isn't the answer just 0 then or something? I mean, we've all learned you can't divide by 0, right? But why, right? Like, why not? What is the problem? What is the issue? It's undefined, great, but why is it undefined, right?
It wouldn't be a real number.
Okay, why? Right? I mean,
Because
so
you have nothing to divide it by?
you have nothing to divide it by. So then we should get an answer of nothing. So wouldn't nothing be 0? Okay, so I'm asking you this question because I think it's worth us talking about for a moment, right? Can we just discuss this for a minute? Why is this a problem? Why is division by 0 a problem? So let me try and convince you. Let me go back here. Okay, so let's try and kind of wrap our heads around why we cannot divide by 0. Why is that not allowed? So we have to go back to our understanding of fractions and what a fraction is. So if I take a fraction like 1/2, the idea here is this. We start with, let's say, a candy bar. And I hate using candy bars because it makes me feel like we're trying to act like children here. But let's just say we have a candy bar, okay? To say that we have half of the candy bar means that you start with the whole candy bar, right? There's the candy bar. And then what I'm going to do is I'm going to use this number 2 to tell me how many pieces to cut it into. So I'm going to cut it into 2 equal pieces. And then I take the number up here, and this is the part of it that I actually want, which is one of the 2 pieces. So I want to take 1 piece from the 2 parts that I broke the candy bar into. Got it? If I write 0/2, well, it's the same story. I take a candy bar, I cut it into 2 equal pieces, and how many of them do I take?
No.
None. So how much do I have? Nothing, right? So it's okay to have 0 on top because you're taking nothing out of whatever, 2 pieces. But the problem comes when you try and reverse it. If I say 2/0, let's say, then we have all sorts of problems here because we're supposed to start with the candy bar, right? And how many pieces am I going to cut that candy bar into? 0 pieces, but I have 1 piece, don't I? I mean, I have the candy bar itself as 1 piece. So it doesn't even make sense for me to put a 0 here when I'm starting with this. And then I'm supposed to take 2 of the pieces, but I don't have any pieces. So it just, I know this isn't like going to completely put this to rest, but I want to try to show you visually like why this operation in our number system just doesn't make sense for us to ever put a 0 on the bottom. Now, calculus is all about this problem. 0 divided by 0. That's basically the heart of calculus right there, is this situation where you have 0 divided by 0. What's that? I mean, because in some sense, anything over itself should be 1, but you can't divide by 0. But if you have 0 on top, your answer should be 0. It's like all these conflicting things happening. And this is what Isaac Newton, who's the father of calculus, he found a way around this. And with that, calculus was born. It's pretty amazing what he did. But it's not that hard to follow what he did. But it's, anyway, save that for later. Okay, so back to this. Anika was saying, Okay, look, we have this expression. We have to be careful because we do not want X, right? We do not want X to ever be 22. Because if X is 22, 22 minus 22 would be 0, and we would have a problem with the domain of this function. It would be undefined, or I said domain of this function, domain of this expression, because we wouldn't be able to define it. Give me any other number and I'm okay. So let's see. How am I going to put the answer in here? I'm going to select A and I'm going to say X can't be 22 and I'm going to be done. Questions? All right, the next one. Before I do it, I want to pose this problem here for you. I'm going to give you two problems. I want you to work these on your own. Okay, and I want to see what people get. So the first problem I want you to do is I want you to do -3 squared. I'm going to give you 3 problems. Then I want you to do -3 squared. And then the last problem I want you to do is, hold on. $12 divided by 3 times. That's a multiplication symbol. That's an old school multiplication symbol. All right. So I want you all to do these 3 problems. Take a minute. I'm going to just put you on mute real quick and turn my video off. I got to blow my nose. I'll give you like a minute and a half. Got enough time, everyone? All right. So I'm going to call on people. I hate to do this, but I'm going to do it. So Dominic, are you there? All right, Dominic. So how you doing today?
I'm doing good. How about you?
Good, good. So number 1 and number 2, Dominic.
Yes.
What do you think?
For 1, I put -9, and then for 2, I put +9.
Okay, what do y'all think, everyone? Good, bad, no, what?
Good.
Good? It's good. So let's talk about the first one. The first one, -3 squared. What everyone needs to understand that this is really -1 times 3 squared. That's really what's going on there. And then if you do order of operations, what's happening is you have to do the exponents first. You square the 3 and get 9, and then you hit it with the -1 and become -9. The second one, because there's a parenthesis here, what that means is -3 times -3. You're multiplying a negative times a negative, which would give you a positive. So the big thing there is that a parentheses makes a huge difference, doesn't it? Huge difference. So we have to be careful when we're doing things. Let me give you another example, and we'll get to more of this later. Let's say I give you an expression. Let's go back to this. What if I give you this expression, x squared plus x? and I ask you to tell me what happens if X is -3. So that means that's like the problem we did a second ago. Let's replace X with -3, right? Let's replace X with -3. When I do that, if I take that X and I replace it with -3, I can write it this way. Or I can write it this way. The first way is wrong. And the reason it's wrong is because when you say X squared, you're squaring whatever the X is. So if it's -3, you have to put it in parentheses and then square it. Do y'all see that you would get two different answers here if you did it incorrectly? If you actually did this top one, you would get -9 and then take away 3, as opposed to this being +9, take away 3. Y'all see the difference between those two? It's not like you get to choose. It's one way and not the other. So this is the correct way. Okay, number 3. I hate to. Let's do this. Does anyone want to volunteer their answer for 3?
I can volunteer.
I'm going to get 2 answers from the class. So let's see. Go ahead. Is it Lizette?
Yes, sir.
Okay, go ahead. What'd you get? Just tell me the answer.
I got 1.
1, okay. Anybody get anything else?
The first time I did it, I got 1. The second time I did it, I got 16.
16, okay. 1 and 16. Those
That's
are the
what I
2
was
answers.
got,
I'm
16.
You got 16 as well?
I got 16 as well.
16. Okay, so
Yeah.
let's do this. I'm gonna do a quick poll. I want to see where the class is. Come on. I'm having trouble with my Zoom. Maybe someone can help me. My controls up at the top of the screen keep on going away. And usually they're pinned there and they're stuck, but there's no option for me to pin them up there. Anyone know what the hell's going on? No? All right, give me a second. All right, I'm gonna create this poll. All right, I'm launching a poll. Now it's giving you choice 1 or choice 2. Choice 1 is the first answer. Choice 2 is the second answer. Let's take a poll. How many of you think it's 1? How many of you think it's 2? This will be interesting. Yeah, it's kind of what I was expecting. All right, that's just about everybody. I'll share the results.
I don't
So-
think I was able to do the poll because I think I'm still a co-host.
Oh, yeah, sorry.
Because I was like, why am I seeing everyone's choices?
Oh, you're seeing. Okay, there you go. Okay, so there we go. All right, there it is. So we've got a lot of people think it's 16. And quite a few people think it's 1. So we're using order of operations here, right? So the order of operations that you are taught, a lot of you are taught, is this thing PEMDAS. Yeah, PEMDAS.
That was my approach to it. So
Yeah.
like multiply first and then divide.
Yeah. So when I learned it, I was told, please excuse my dear Aunt Sally. That's the way I learned it. But I think there's a couple of other things that are taught. So the PEMDAS, hopefully everyone has seen this, means you start with parentheses. You always do what's in parentheses first. Then you do exponents next. Then you do multiplication, then division, addition, and subtraction. That's kind of like the way it's taught. But 11 of you didn't do that, like the way I just described it. 11 of you got 16, which to me looks like what they did. The 11 people that did this did the 12 divided by 3 first, and then got 4, and then multiplied by 4, got 16. So they just completely ignored that there was multiplication and division, just went like left to right, like they were reading a book, right? Those 11 students are correct. That is right. That is the right way to do it, which leads me back to PEMDAS. A lot of times it's not taught correctly. or when it's taught, it's not emphasized enough and students forget it. When you look at this PEMDAS, multiplication, division, and addition and subtraction are equal. In other words, it's not multiplication before division, and it's not addition before subtraction. They're equivalent. So what you always do is if you see multiplication, division, you work left to right, the way you read a book. In fact, if you get your calculator out and you type in 12 divided by 3 times 4, it's going to give you 16, because the calculator knows how to do it correctly. So these are always done left to right. Left to right. The way you'd read a book. Same with this, left to right. So the correct answer is 16. So good, that means at least 6 of you kind of learned something here today, or relearned it correctly, hopefully. All right, I got off topic there, it's okay. Let's get back to this. So here we want -2 squared. So that -2 is parentheses, so that's -2 times -2, that should give me 4. Here, there's no parentheses. Oh, wait a minute, but look, this is not -2. This is 2 to the -2. What is that? So this goes back to properties of exponents. We need to, there's, if you open up the ebook, okay, and look at this section R2, there's a whole thing where it'll give you a review of all the properties of exponents. So there's properties like, you know, if you have x to the n times x to the m, that's when you add the exponents. You know, what happens if you have x to the n over x to the m? Well, that's when you subtract the exponents. This all look familiar? All these properties are in the book. This particular property is this one. If you have x to a negative power, it's the same as 1 over x to that power positive. That's the property I would use here. So I'd rewrite this as, let's see, Caitlin. Did I already call Caitlin? No. I don't think I did. Caitlin, you here?
I'm here. Sorry.
Oh, there you are. Okay. So Caitlin, using this property, how could I rewrite this? Using this property in the box, how could this be rewritten? So the x is like, oops, the x is like the 2, right? And the -n is like the -2. So according to this property, it can be rewritten how?
1 over.
Oops, I didn't mean to do that. Hold on. Yeah, keep going.
1 over 2 -2.
So you're almost, that's almost correct. One, these colors are not matching. 1 over 2 to what power? Notice here that the -n becomes positive n.
Oh, so it's just 2.
2, 1 over 2 to the 2. And Caitlin, 2 to the 2 means 2 squared, right? Just 2 times 2, which is?
Yeah. 4.
4. So this becomes 1/4. That's it, we're done. It wants our answer as a fraction, an integer or a fraction. So it should take this 1/4. There we go. All right. 2 to the -2 is the same as 1/4. Next time you're at HEB, go to the deli department to get some like roast beef or something and ask the person behind there for 2 to the -2 pounds of roast beef. And then they'll probably spit in your food. It's 1/4 a pound, right? That's all it is. Oh shit, what happened here? This looks terrible. All of a sudden we've like gone from 2 to the -2 to this. All right, so we've been thrown into the fire here. Let me do this. I'm going to copy this and take it to another page. I need more space for this. So the instructions here are to simplify the expression. Express the answer so that all exponents are positive. If an exponent is 0 or negative, assume that the base is not 0. So that's just to make sure we don't get like 0 to the 0. All right, so we want to simplify this. That means we want to use all these properties of exponents to try and clean this thing up. All right, let's kind of tackle this one thing at a time. Here we have 2 to the third, negative 2 to the third. Here we have 3 to the third. Those are just numbers. I can figure out what those are, can't I? So let's see, Zachary, you're up.
So you just want me to do the
What's
highlighted
the
ones?
yellow? Give me the yellow part. What's the yellow part turned into?
So for the numerator, I got I kind of simplified to that to -6.
Okay, so how did you do that?
So I basically went -2 times -2 times -2.
That's the correct thing to do, but then you said -6. So
Oh, did I?
careful
I'm
there.
sorry.
No, it's okay. -2 times -2, those two would give you 4, right? And
Yeah,
then
that's
times
sorry. Sorry,
-2.
that's -8. Sorry.
-8. Yeah, no, don't apologize. So that what Zachary did there was exactly what a lot of students will do when they get going too quick in their minds. Just kind of multiplying the 3 times the -2 and getting -6. Remember that it's, you know, multiplying it 3 times. So just take your time with the multiplication, you get -8. Okay, what about the bottom? Same thing here, be careful.
I believe that is 27.
27, good. So 3 to the 3, that's 3 times 3 times 3. That's 27. All right, that's good for the numbers. Now, next thing I'm going to look at are the variables. So let's see here. In terms of x's, I have an x to the 6th here and an x squared here. I don't have any x's anywhere else, do I? So I can deal with those kind of on their own. And I can treat it like I have x to the 6th over x squared. And is it Michael Guerrero? Is that right?
Yeah,
How's it going, Michael?
good.
Good. How do you feel about this right here?
Pretty good. I think you just subtract the exponents.
Subtract. So you do 2 minus 6 or 6 minus 2?
6 minus 2.
6 minus 2. And that'll give you x to the 4. And where do you put that, Michael? Does that go on the top or does it go on the bottom? Where do you position this x to the 4th? That's the answer.
I believe it goes on top.
On the top. All right. Now, Michael, had it been -4, you would put it on the top and then you'd move it down and make it positive. Okay, so x to the 4. Does anyone have any questions so far? Good, thank you, Michael. All right, now when it comes to the y's and the z's, do you all see that this y and z are trapped in that parenthesis? We have to free it from the parenthesis first. So I'm going to do that over here on the side. What's y, z to the 3rd power? Now there's multiplication happening here. So when you have this, there's a property here. I'll put the formula below it so you can have it. If you have x times y to the nth power, you can do x to the n times y to the n. In other words, as long as there's multiplication in here, has to be multiplication, and you have the power out here, you can apply the power to each one. So is it Sarah? Is it S-A-I-R-A-H?
That's me.
Oh, that's Sana.
So Syra is my first name, but I go by Sana. That's my middle
Sana.
name.
Okay, I'm going to change it here on here so when I can kind of connect who you are. All right. So you say Sana?
Mhm.
Okay. All right, I'm gonna go, you've already participated today, so I'm gonna ask Javier. Oh, no, sorry, Lizeth is actually participated today. Hey, Lizeth. Where are you at?
Hi.
Hi, so I got your thing about having trouble with the PDF thing. Just get with me if you continue to have issues with that,
Okay.
okay? Maybe after class or during my office hours or something.
Okay.
Okay, let's see, Jose, how about Jose?
Yes.
Yeah, I think you've participated, but go ahead and tell me what you got here. What would this become?
I think it will become y to the third power times z to the third power.
There you go. And let's just put that back up here. Let's put y to the third, z to the third, and then on the bottom, we had the y to the fourth, z squared.
Z squared.
Okay, so everything I have down here is kind of like my scratch work. This is where I'm kind of like keeping track of everything. Up here is where I have, okay, this is what I'm saying it's equal to. It's like that equals that. Now, I'm still not done. I need to now put these y's together. So Javier, you there?
Yes, sir.
Okay, what do you got for this?
Would it be negative or?
Yeah, this will become y to the third over y to the fourth. You're gonna do y to the, you do the what minus what here?
3 minus 4,
3 minus 4, and 3 minus 4 is
-1.
-1. Now you're gonna put that answer on the top. I'm gonna go ahead and write it down, even though we're gonna wind up dropping it. Here's the y to the -1. Still have the z to the 3 over 27. The y's I've taken care of. I still have the z squared down here. Hey, by the way, if you can do this a lot faster than I'm doing it right now, like without having to show all this detail, good for you. All right. I just want to make sure that I go through all this little detail since it's the first time we've done something like this. Everyone clear on what happened here? This became that. Now, because it's a negative exponent, I'm going to drop it to the bottom and make it y to the first power on the bottom, but I'll do that on the next step. I'm not going to do it yet. I still need to take care of the z cubed over z squared. Any questions? I'm going to move this down here. Any questions? Alyssa, what do you have for this? Z cubed over z squared. Is Alyssa here?
Sorry, you cut off when you said my name.
Oh, I cut off, I'm sorry. So what do you have for this z cubed over z squared part?
Just Z.
Just z. You could say z to the first power, but that's just z, right? So z. All right, so I'm gonna write everything. This should be my final answer. I'm gonna have -8 on top, x to the fourth. This y to the -1 is gonna come to the bottom and join the 27. And then these last two z's left me with a z to the first power, which I put on top. And this should be it. Questions?
Would it be okay for the y to the third power and the y to the fourth to just put the y on bottom at first?
Oh, yeah.
Okay.
Yeah, that's what kind of what I'm saying. Like, if you don't need to go through all that, that's okay. I just want to make sure you understand, you know, it starts out as y to the -1, but then it gets dropped down.
Okay, thank you.
You could also do it this way. If you don't like that, if you prefer, you could say, oh, look here, I cancel 3 of those, leaves me with a 1. That becomes just a y to the first power. If you do it that way, that's okay also. I need to check my answer though. Let me go back to the assignment thing. Okay, I'm gonna hit this button to make a fraction. It was negative, oh, it was -8. I've already forgotten, x to the fourth. So x, I can use this key right here to do to the fourth, or I can use that, what's called your caret key. It's that key right there above the 6 on your keyboard. That will also do an exponent. And then it was z. And then over 27y. I think that's what it was. Yeah. There we go. Next question. Ooh, this one looks pretty nasty. By the way, while I'm talking about this, something else subtle that you may have noticed here. This is just something that I picked up as I was a student of math. When I write a Z, I strike my Z's with a line. And that's so I can distinguish them from my 2's, because my 2's and my Z's look a lot the same if I don't strike the Z. As something, if you're going to do a lot of math later, there's certain little things that you may want to start to do for yourself to help yourself, especially when you have a problem that's like 3 pages long and you got, you know, all these things, symbols everywhere and 2's and Z's and all this stuff. You want to keep track of it. I do another thing on my T's. When I write T, I curl the bottom of the T. And that's why I don't confuse it with a plus symbol. Right. So these are just little things. Take it or leave it. Let's move on. Next problem, another simplification problem. Okay, so for this one, we have a lot going on here. There was a lot going on. So, and I should point out that, look, when it comes to algebra and it comes to properties of exponents, there's many different paths that you can go down that would still lead you to a correct answer as long as you don't break any rules. So you might do it one way, I might do it another way. As long as we follow the rules, we should get to the same result. So the way I do this might be slightly different than the way you would do it. What I'm going to do initially is this. I'm going to use this property. It says that if you have a fraction raised to a negative exponent, that you can flip the fraction over and then change it to a positive exponent. So a fraction to a negative exponent is the same as that fraction flipped, but raised to a negative. That is a property of exponents. So the first thing I'm going to do is kind of realize that this whole top is like the X and like the Y, and I have a negative exponent here. So I'm just going to flip the whole thing over and make it a positive 2. That's what I'm choosing to do first. So this whole thing is equal to 8y to the negative 7 over 6x to the negative 6, all to the positive 2. Okay. Now, the next thing I'm going to choose to do is I'm going to look in the parentheses and I'm going to realize I have a negative power on that y and I have a negative power on that x. So that means that y to the negative 7 can be dropped down and the x to the negative 6 can be pushed up. So anytime you have a negative exponent, wherever it lives, you can push it to the other. You know, if it's up, it goes down. If it's down, it goes up. So I'm choosing to do that as my next step. Again, this is the way I'm choosing to do it. You might have done it a little different. The 8 stays. This x to the negative 6 comes up as an x to the positive 6. The 3 on the bottom stays. This y to the negative 7 now comes down to the bottom, becomes y to the positive 7. And I still have this whole thing squared. The next thing I'm going to do is use this property. If you have a fraction to a power, you can apply the power to the top and the bottom separately. Anytime you have a fraction, that whole fraction is raised to a power, you can just apply the power to the numerator and denominator individually. So I'm going to apply this 2 to the top and the 2 to the bottom. So let me do that on my next step. Be careful here. You have to take the entire numerator and square it, the entire denominator and square it. It's critical that the 8 and the x to the 6 are in parentheses. Why is that critical that I included the 8 here and the x to the 6 in parentheses? What if I had done this? I don't even know how the hell you'd write that. Could you, like, if you square that, that notation doesn't really even make sense. The square, this would be wrong. The squared is not just acting on this, it's acting on both. And that's why I put the whole thing in parentheses. Any questions up to here? I'm gonna keep going. I haven't called on anyone on this one because I wanted to work through it myself. Okay, next thing I'm gonna do is a property we looked at on the previous one. Where was it? This one right here, that if I have two things multiplied to a power, I can apply the power to each one. I'm going to use that property there. So the two things I have multiplied here are this 8 and this x to the 6th, and then it's being squared. So I'm going to write that as 8 squared times x to the 6th squared. And then over on the bottom, I'm going to do my 3, same property, 3 squared, and then y to the 7th squared. I'm almost there. Time to square the 8. 8 squared is 64. I'll square the 3 on the bottom, that's 9. Now, what happens here? Let's call on somebody. This green part right here. Let's see, I feel, did I call it Alyssa? I did, right?
Yes, sir.
Yeah, I forgot to mark you down. Okay. Araceli,
Yes,
how's it going, Araceli?
it's going good.
Good. Do you remember, or does it look familiar, like how you do this? X to the 6th, but then squared?
Yeah, I believe you add them.
Add them? What's the
Yeah.
other thing it could be? You could either add 6 plus 2 and get 8, or you could do 6 times 2, right, and get 12.
Yes.
So you have to remember which of those it is, right? So
Yeah.
when I was a student, I actually, in the very beginning of my algebra life, I had trouble remembering which one. You know, I struggled with remembering. So here's the way I finally figured it out, all right? I gave myself an example, like x cubed squared. And I would say to myself, what do I do? Do I add them? Is it x to the 5th or is it x to the 6th? Do you understand what I'm kind of thinking through here?
Yes.
So the way that I finally figured out what it is to think about what x cubed is. Okay, so what is x cubed? It's just x times x times x, right? That's what it is.
Yeah.
And then I want to take that and I want to square it. And when you square something, that means you multiply it times itself. So that means I'm going to take the x times x times x and then multiply it times itself, x times x times x, right?
Mhm.
And how many x's do I have? Total.
6.
6. So it has to be this answer, right?
Yeah.
Has to be that answer, which means that I needed to have multiplied those.
Okay.
So now you don't want to have to do that every single time, all right? But you finally get to a point where you remember it, right? But if you're doing something and you forget, you can always do this to kind of remind yourself. Let me show you the other way where it's added. It's added when you have this. That's when it would be x to the 5th.
Okay.
And the reason, and the way you can remember that is this. What's this? X times x times x, right? Times x times x. How many x's do we have here? 5, right? So that's x to the 5th. And that means you add those. Okay, so Araceli, what I'm actually using here is a property that says x to the n to the m is x to the n times m. That's the actual formal property of exponents.
Okay.
So that's where, Araceli, what does this turn into then? X to the 6th, all of that squared turns into what?
Exponent 12.
12, okay. And then same principle here with the y. We would get y to what power?
Y 14. Exponent 14.
Y to the 14. We should be there. Lots of different properties of exponents mixed into a problem like this. All right, good, good. Let's go put the answer in. 64 x to the 12th. 64 x raised to the 12th over 9 y to the 14th. I'm doing okay. All right, we're only on problem number 10. All right, so this one, find the value of this expression. So I don't think I'll work through this one. You're going to replace the x with 4, replace the y with -1, square each one of them, add them up. So let's see, if we square 4, we get 16. We square -1, we get 1. So this should be the square root of 16 plus 1, 17. Oops. All right, scientific notation. This is all pretty straightforward stuff. This is a review, and it's actually not that important for this class. So I think you can handle that part. Let me see here. Yeah, and I want to leave the last two to you. I don't want to talk about them. I want to see how you do on those. Okay, so I'm done with this section, okay, in terms of what I want to help you with. If you don't remember scientific notation, I'm sure you can Google it, YouTube, go watch some stuff on scientific notation. It's how to convert from one notation to the next. And then the last two, I want you to just think about, see if you can figure out on your own. If you have questions, we can talk about it next time. So let me save my work and let me go back to the homework if I can find it, because that's only one of the two sections. Oh, sorry, I should have turned that poll off a long time ago. Polynomials. All right, this section is a lot shorter. It's only 9 questions. And most students coming into this class do very well with this section because, I don't know, for some reason, it's stuff that just seems to look more familiar to them. Let me bring it in. So I only have 10 minutes, so I'm not going to be able to go through all of this. Here it's asking you to calculate this or express this as a single polynomial. So what they want you to do is like distribute the negative through, collect like terms together. So, you know, again, this is stuff you probably have seen. It's just maybe been a while. This one right here, same thing. I want you to distribute the 5 through, distribute a -2 through, collect like terms. Remember that when you're working through the homework, if you need help, you can ask for help with the button here. Sometimes there's videos that actually walk you through. Now, these videos were not done by me. Okay, these are done by the publisher of the book. But, you know, just realize that they're here.
To add polynomials, all we need to do is combine like terms.
Okay, so that's not me. That's some other guy talking. All right. And let's see, more polynomial stuff. Collecting. Here, multiplying through. Here, this one I want to do. Let's see what the next one is. Let's do this one. Yeah, we'll do that one, and then we'll do this one. All right, maybe not that. I'm gonna kind of make up my own problems, I think. Okay, so I'm assuming you know how to add and subtract polynomials. Let's multiply 2 polynomials together. So let's take x plus 3 and multiply it times x minus 5. So if I ask you to multiply these, a lot of you are going to say FOIL it, right? How many of you remember hearing that FOIL thing, right? FOIL, yes. Okay, so FOIL is cute, right? FOIL is a very cute thing. It helps you like actually run through the multiplication process. It stands for first, outer, inner, last. Okay, that's what it stands for. I do not teach FOIL. Okay, and the reason I don't teach FOIL is because of the problem I'm going to give you after this. FOIL only works when you have 2 things multiplied by 2 things. Once you go past that, FOIL doesn't work anymore. So the way I would recommend you look at this is this. start with the first term you have here and pass it through the other parenthesis, multiply through. Once you've done that, then move to the second term and pass it through the other parenthesis. Once you finish that, you're done. All right. So let's actually do that. First multiplication I'm gonna do x times x. What's x times x, Miguel? Where's Miguel? Miguel.
Would it be x squared?
X squared. Okay, so the first multiplication, I'm gonna get rid of these so we can go through them. Okay, so Miguel's saying here times here, that's x squared. Okay, good. Now here to here,
Negative 5x.
negative 5x. Okay, and then now we move to the inside and do this one, which is
Positive 3x.
good. And last piece,
Negative 15.
negative 15. Okay, can you collect any of those together, Miguel?
Negative 5x and 3x.
Okay,
Be negative 2x.
okay. Minus 15. We're done. Good. Miguel, you said that with a lot of confidence, as if this seems very simple to you. That's good. All right. So Miguel, I hope you won't mind if I then pick on you. Not pick on you like to try and be mean, but I'm curious because you sounded very confident with that, how you would multiply that. Like, do you have the same confidence level and comfort level with doing that as you did the previous one?
Just a bit, but
Okay. So do you, the way that people learn this is different. My recommendation is to do what I just instructed, that is start with the first one, pass it through. Okay. After you're done, move to the next one, pass it through, and then you're done. This works for no matter how many terms you ever have. Let's say I did x squared plus x minus 4 times x to the third plus x squared minus 4x plus 7. If I wanted to multiply this together, it may look like a terrible thing, and it is pretty terrible. But if you follow the procedure here, pass it through. You'll have 4 terms when you do that, right? Then you'll move to the next one. Pass it through 1, 2, 3, 4. Now you'll have 8 terms. Then you move to the next one, pass it through 1, 2, 3, 4. You're going to have a total of 12 terms, and then you collect the like ones together. I think that's more powerful than FOIL, because FOIL only works when you have 2 and 2, but it's the same procedure for all of them. Okay? And we're good? Understand? You'll have practice on your homework for this. Let me get back to the homework. So for this one, I would do, this, and then pass the 2 through here, here, here. Collect like terms together. You're done. Okay, what about this? X plus 1's, let's do x plus 5 squared. Raquel, are you there?
Yes.
Okay, Raquel. Raquel, what's the most common incorrect answer you think people give for this? That's not what you were expecting I was going to ask you, right?
I want to say probably x plus 25.
X squared plus 25. That is the most frequent wrong answer that's given. So what this student did was they just said, oh, I'm going to square the x and square the 5 and just add the answers. That's wrong. Now, the only time you can do that, remember that property I gave you just a second ago where you have 2 things, you can apply the power to each one? That property we talked about earlier, that only works if this is multiplication. If that's addition or subtraction in here, it doesn't work. So you're not allowed to do this. Instead, Raquel, what do we have to do? How would you do that, Raquel?
I'm not too sure.
Okay, so what does it mean to square something? If you square something, that means you're going to take something and then multiply it times itself, right?
Yes.
Okay,
Uh-huh.
so we're gonna take the x plus 5 and we're gonna multiply it, right, times itself again. And now you have to do that multiplication that we just did a second ago, where you start here, pass it through, and then move to here and pass it through. Understand, Raquel? The difference?
Yes.
Okay.
Uh-huh.
I'm almost out of time, so I'm just going to give everyone the answer here. When you multiply that through, you'll get this. And then you'll collect your like terms and get that. So just don't make this mistake. All right, let me see here. There's not many more of these. That one is basically just multiplying through, okay, using that little thing I showed you here. Same thing that Raquel and I just talked about. You're going to multiply something times itself. When you square it, you put them side by side and then multiply through. Ooh, cubed. That means you have to do it 3 times. 3 times times itself. I'm curious to see how you'll handle that. That's the last problem. I always like to leave like the last problem or two for you, just because they might be a little more challenging and I want to see what you do with them. All right, that's it for today. Like I told you at the beginning, this is not the way normal class is going to go. All right, I'm not just gonna be cranking through homework and just kind of saying, oh, remember this formula? I mean, later it'll be like I'm presenting it for the first time. So I recommend, if any of this was challenging to you, that you go back and you open up that book for the class. It's right here under e-contents. Go to the chapter review, go to section 2. Come on. So here's R2 Algebra Essentials. And if you go through the ebook, you'll be able to find places where it has like a summary of all the properties. Let me get to it. They define, so here's where we start getting the properties of exponents. You know, what does a to the n mean? What happens if you have a negative power? Oh, look at all these laws, properties of exponents. It's all in the ebook if you need to go back and refer to something, you know, to have a nice place where all the formulas are. All right, that's it for today. What is expected from you is that by the time we meet again, you will have gone into that online homework system. You'll have done the homework for R2 and R4. Do it to the best of your ability, all right? And then reach out if you need help. Be ready for a quiz over any of the material from those sections. Any questions? Okay, thank you for your participation. And for those of you who had your cameras on, great. For those of you who didn't, you know, we'll see. Maybe next time we'll see you. It's your grade, so. I'll hang out if you have a question.
Can I stay so I could talk to you about the PDF thing?
Yes.
So I have no problem like taking pictures on my phone and then transporting it to my laptop. I've done it before.
Okay.
My problem was, so you said how like 3 separate pictures.
Yeah.
My problem was like heading over to the gallery on my laptop and then composing that and then creating it a PDF. That's when I struggled. But I
Okay,
saw
so you can get
I'm sorry.
You can get your 3 pictures turned into 3 different PDF files on your computer. Is that my understanding?
I didn't even know how to do that actually.
Okay, so you just got your pictures to your computer.
Yes.
What kind
Yes,
of what kind of phone do you have?
I have an iPhone.
So there's something I believe called Cam Scanner.
Cam scanner.
Yeah, and it allows you to turn all your pictures into a single PDF file on your phone before you send it to your computer.
Okay.
What I would do, because I don't have an iPhone, so I can't really.
It's an app?
Yeah, it's called Cam Scanner. And I know some iPhones already have something built into them that allows you to convert pictures to a PDF without an app. I think you have to bring up the Notes app or something in the
Mhm.
phone. We have time. I don't want you to be stressed out about it. This is why I'm doing it now, because by the time we get to the test is when we really need to be able to do it. So
Mhm.
why don't you look into that app and see if you can't figure that out? And then, if you can't, next time we meet, we can talk again. And maybe I'll have more information on that by the time.
Okay.
Does that sound
Okay,
fair?
cool. I found the app actually. It's the first one that pops up.
Okay, yeah, try
Yeah,
it. See how
I'll definitely like play around with that. I saw your video and I saw like towards the end where you're like, oh, like I want to see like who watched the orientation video.
Mhm.
And I was like, well, I guess I'll just have to like improvise. I wanted to show you that I actually watched the video,
No, I'm glad you did that. Thank you. I mean, I'm gonna check you off here. I mean, I already showed that you did it. So
Uh-huh.
in terms of like participating in that assignment, you're good. But let's just make sure we get it worked out and
Yeah,
we'll
of
talk
course.
next time. Okay?
Alrighty, thank you so much.
All right, no problem. Have a good one, Lizette.
Thank you.
Ashley, are you there? You have a question or?
No, sir, I was just looking at the problem.
Okay. All right. Are you good to go? Because I've got another class I've got to head to. Okay. I think it's just me.